Okay, so I'm going to be talking about Math 1 and Unit 2, and it is all about triangles. We're going to start, so the very first quiz is on what is a triangle, what are the parts of a triangle, how to name a triangle, different types of triangles, all sorts of things like that. So we're going to go over that. It's largely just a lot of definitions and understanding what those definitions mean. So the very first definition they want you to know is a triangle. When you get to your quiz, it's going to give you, ask you what the best definition for a triangle is. Obviously, a triangle has 3 sides, so you're going to look for that. It's not 4 sides or 2 sides, as we know. Its formal definition that you'll find in Apex is a figure formed by 3 segments that connect 3 non-collinear points. So that sounds really fancy schmancy, but really all this means is that you're going to get a figure, or aka a shape, that is formed by 3 line segments that are connecting these 3 points that don't lie all in a row. Non-collinear means that they are not in a single line. So as, for example, this one, if they were collinear, and you had segments connecting them, it would look like that. So you could only fit 2 segments in there to connect those 3 points. So non-collinear points allow you to form your triangle. Okay. Once you have your triangle, the different parts of it, these points, the non-collinear points, are called a vertex. Multiples together we call vertices. Okay, this right here is your side. I mean, this is probably all really pretty obvious to you guys. So the segments that connect your vertices are your sides, and then the 2 segments that come together at one vertex forms an angle. Okay, so it's important to understand what we mean by side and angle and vertex. Also, an important thing to note is that this angle right here, where I've just marked, is opposite to this side. Okay, so this angle is opposite to that side. There will be a few questions about which angles are opposite of the line segment, or which line segment is opposite of the given angle. So that's important to note. Also, with triangles, you need to understand how to name them. So I'm going to erase these words. I'm going to put up here some letters for our vertex, or our vertices. Okay, so there we have P, Q, and R. For our vertices, to name this triangle, there are many options. So we're going to put a little triangle, and then we're going to list our vertices, the names of our vertices, in a clockwise or counterclockwise order. In other words, we're going to go around the triangle we'll just keep going, well, yeah. So it's going to go P, Q, R would be one option. Instead of starting with P, you could start with Q, and then it'd be RP. This is all clockwise right now that we are moving, so I could go triangle RPQ. So those are my 3 options if I go around the triangle clockwise. I could go around counterclockwise. So if I started with P, moving counterclockwise, I'm going to have P, R, Q. See the difference between them. But it's still a name for the triangle. I could have triangle RQP and triangle QPR. Okay, those are all of the options for the names of this triangle. You will have questions that ask you what choices given to you could a triangle be named after, and you'll have to select them by going either clockwise or counterclockwise. If letters start popping in, let's say that there's a point right here and they're calling it X. X cannot be in the name of the triangle. It must be a vertex to be in the name of a triangle. Okay, Let's see. Oh, given this one, let's talk about that opposite sides that are opposite. So given vertex P, which side is opposite to vertex P? It would be segment QR. Okay. Which angle is opposite of segment PR? So from P to R, the angle opposite to it is Q. Q does not help create, is not touching P to R, therefore it is opposite to it. So those are your opposites. Let's see, P, Q, and R are your vertex. We covered that. Line segments, you have 3 different line segments on here. We have the line segment P to Q, and line segment P to R. We also have the line segment Q to R. Okay, those are all line segments, and those line segments are the sides of our triangle. Okay, so that's really most. Let me double check, make sure I didn't leave anything off from there. Yeah, that's pretty much it. Oh, there is one thing. Okay, this is, I noticed this is kind of funny. So there, you'll get some questions that ask you what line segment. They'll give you like the name of the triangle or maybe a picture of the triangle. So let's say that I will draw a new triangle on here and we'll start all over. And we'll call this one ABC. Okay, so A, B, and C are the vertices of the triangle. And so you might get a quiz question that says, what side or what segment is between the angles A, B? So this is the symbol for angle that says angle A and angle B. So what segment sits between angle A and angle B? What's this segment right here? So it would be line segment AB. That would be our answer. Okay. All right, so let's talk about different types of triangles. For example, an acute triangle. Okay, I'm going to go ahead and erase all of this. Even our definition, we don't need that anymore. Okay, so an acute triangle is any triangle where all 3 angles, okay, there are all 3 angles, they are all less than 90 degrees. All angles are less than, whoops, I was going to put a big old 0 right there, and we'll just turn that into a 9. They're less than 90 degrees. That's an acute an acute triangle. Okay, acute triangles, there's one special type of an acute triangle. Never mind, we'll come back to that in a minute. Well, there's one type. It's where all 3 angles are equal. It's called an equiangular triangle. We're going to talk about this one again in a minute. So equiangular, whoops, forgot my U. Equiangular triangle has all 3 angles that are equal and they all measure 60 degrees. Okay, another type of triangle is an obtuse triangle. So, oh, there's the dog. Sorry about that. Okay, so an obtuse triangle is a triangle where one angle is larger than 90 degrees. So you'll have one that measures, so let's say this angle is 100 degrees. Then that's an obtuse triangle. So one angle is greater than 90 degrees. So acute triangles less than 90 degrees, obtuse triangles greater than 90 degrees. And a right triangle has one angle that measures 90 degrees. Okay, so on acute triangles, all three angles can be acute. Or in a triangle, you can have all three angles being acute. You could have two angles being acute and one obtuse. You could have two angles acute and one right, but you cannot have more than one right angle, and you cannot have more than one obtuse angle in a triangle. So the acute angles, you can have up to three, only one obtuse and only one right angle. And there cannot be an obtuse and a right angle in the same triangle. They are separate, never in the same. Okay, so those are the types of triangles based off of their angles. There are different types of triangles based off of their sides. So let's erase this. You can have a scalene triangle. That means that all three sides measure a different distance. So for example, maybe you have 3, 6, and 8. Okay, so that would be a possibility for a scalene triangle. Just all three sides cannot be equal. They're all different or unequal. Okay, another type of triangle is an isosceles triangle. Isosceles triangles have two sides that measure the same, or two sides that are equal. Now, an isosceles triangle can, well, here, I'll give you an example of one first. Let's say that this is 2 and 2, so those two sides are the same measurement. That makes them isosceles. A scalene triangle can come in any of the triangles. It can be acute, obtuse, or acute, obtuse, or right angle triangles. So all three triangles can be scalene. All three types of the angle triangles can be scalene. Isosceles can be a right triangle as well. It can be an obtuse triangle, and it can be an acute triangle. So it can come in all three as well. Okay, there is a third type based off of the side measurements, and it's actually the third type is a subset of isosceles, meaning that two sides are equal, and actually we're going to start with so all three sides are equal. It's called an equilateral triangle. I'm sure you've heard of it. So all three sides are going to be equal. When we make note of all three sides being equal, we put little tick marks in them. So all three sides are equal here. In this case, an equilateral triangle is always acute. You cannot have an equilateral triangle that is also obtuse, and you cannot have an equilateral triangle that is also a right triangle. So it will always be acute. Because actually, an equilateral triangle has angles that are the same, so it's also equiangular. And I told you previously that equiangular triangles are, each angle measures 60 degrees. So all three angles in an equilateral are 60 degrees. And that is everything for this first quiz, 2.1.3. Good luck. Let me know if you have any other questions.